At this very moment, over 68% of the world's fresh water is locked inside ice. Most of it sits far from daily life, frozen across Antarctica, Greenland, and high mountain glaciers. It feels distant, stable, permanent. But ice is not just frozen water. It is one of the planet's most important control systems. If all the ice on Earth melted, global sea levels would rise by approximately 65 to 70 meters. This estimate comes from satellite data, ice sheet measurements, and paleoclimate records studied by NASA and climate research institutions. That amount of sea level rise would not flood coastlines. It would erase them. Entire cities would disappear beneath the ocean. New York, Miami, Lagos, London, Shanghai, Mumbai, not partially submerged, fully underwater. Hundreds of millions of people currently live less than 10 meters above sea level. They would be displaced long before the melting was complete. This would represent the largest forced migration in human history, unfolding over decades, but with no true endpoint. But rising water is only the most visible effect. As ice melts, it releases enormous volumes of fresh water into the oceans, and oceans depend on salt concentration, salinity, to function. Salinity differences drive global ocean circulation, including a system known as the Atlantic Meridional Overturning Circulation, or AMOC. This current moves warm water northward and cold water southward. It helps regulate climate across Europe, North America, West Africa, and parts of the Southern Hemisphere. Scientific models show that large freshwater influxes can weaken or disrupt this circulation. Evidence suggests this has happened before. During the Younger Dryas period, roughly 12,800 years ago, a sudden release of glacial meltwater into the North Atlantic coincided with rapid cooling across the Northern Hemisphere. If a similar disruption occurred today, temperature patterns would shift dramatically. Northern Europe could experience colder, harsher winters. Other regions would face intensified heat waves, weather systems would become more erratic, rain would no longer fall where it historically has. Some regions would experience persistent flooding, others would enter long-term drought. Modern agriculture depends on predictable seasons. When those patterns break, crop yields fall. This would not cause an immediate global famine, but it would destabilize food systems, raise prices, and increase geopolitical tension, particularly in import-dependent nations. Then there is the ocean itself. Ice plays a critical role in reflecting solar radiation back into space. This is known as the albedo effect. White ice reflects sunlight. Dark ocean water absorbs it. When ice disappears, the planet absorbs more heat. This accelerates warming, which causes more melting, which leads to even more heat absorption. This feedback loop is one of the most serious concerns in climate science because it is self-reinforcing. As ocean temperatures rise, oxygen levels decline. Warmer water holds less dissolved oxygen. Marine ecosystems are extremely sensitive to this change. Coral reefs, already under stress, would collapse. Fish populations would decline. Food chains would destabilize from the bottom up. Phytoplankton, microscopic organisms that form the base of ocean life and produce a significant portion of Earth's oxygen, are also affected by temperature and nutrient shifts. The ocean would not die, but it would become less productive, less stable, and less capable of supporting life at its current scale. On land, ecosystems would fragment. Species adapted to cold environments, polar bears, seals, alpine plants, would lose habitat entirely. Extinction rates would rise, particularly among specialized species with limited adaptability. Human systems would struggle as well. As coastlines disappear, national borders would be redrawn by water, not law. Ports would vanish. Trade routes would shift. Entire economies built around coastal access would collapse or relocate. This would not be a single global catastrophe. It would be a chain reaction, ecological, economic, and political, unfolding over generations. And here is the critical distinction. Earth has existed without ice before. Geological records show long ice-free periods in the planet's past, but human civilization has never existed without it. Without that stabilizer, Earth would not instantly become uninhabitable. It would become unpredictable. And unpredictability is where complex civilizations fail. Ice appears passive, silent, fragile, but it holds coastlines in place. It moderates temperature, it governs oceans, weather systems, and life cycles. If all the ice melted, the planet would continue, but the version of Earth humanity depends on would be fundamentally altered. And survival would no longer be about technology or intelligence, it would be about adaptation, scale, and time.